In this video, I will show you how to take measurements using 4 instruments: a ruler, a vernier caliper, a micrometer, and a triple beam balance. Feel free to skip around in this video or to replay parts as needed. First up, rulers. These simple devices usually have 2 systems of measurement: the imperial system down here labeled with inches, and the metric system on the other side labeled with mm. We do not use inches in this class, only the side labeled mm, where mm stands for millimeters, or 1/1000th of a meter. The numbers labeled on the metric side of the ruler represent the centimeters, or 1/100ths of a meter. So this is 1 centimeter, and this would be 13 centimeters. To measure an object like this pencil, we need to make sure one end lines up with the first marking on the ruler. Never measure from the very end of the ruler unless the scale actually starts there. In this case, the scale starts here on the first tick. To determine the length of the object, we simply count how many tick marks the object extends along the ruler. So I'm going to count the centimeters. 1, 2, 3, 4, 5, 6, 7. At least 7 centimeters. And I'm going to estimate 2 additional tick marks. Okay, so right here is where I think the object ends. And so now I'm going to add 7 centimeters plus 2 millimeters, where 2 millimeters is equal to 0.2 centimeters. To go from millimeters down to up to centimeters, just divide by 10. Millimeters to centimeters, divide by 10. Now I add 7 centimeters plus 0.2 centimeters gives me 7.2 centimeters. So that's the length of the pencil. As you can see, using a ruler is pretty simple. Now we have the vernier caliper. With proper use, this is a more accurate measuring tool than the ruler. It's also more precise. The smallest increment of measurements on the ruler is 1 millimeter, whereas the smallest increments of measurement on the vernier caliper is 0.05 millimeters, labeled here. So let's go over the parts to this instrument. First, we have the external jaws, here and here. These are used to measure the external lengths and widths of objects like this black disc. We have the internal jaws right here. These are put inside of hollow objects and can be used to measure the inside widths and diameters of hollow objects. We have over here the depth measuring rod. This extends down and can be used to measure the lengths inside of hollow objects. We have the main scale, which is this, the biggest scale up here. It looks similar to a ruler. You notice it's labeled mm. Each tick mark on the main scale is 1 millimeter. This is 10 millimeters, 20, 30, so on and so forth. We have the vernier scale, which is this little scale down here, and it's labeled again with the 0.05 millimeters, and each tick mark on the vernier scale measures 0.05 millimeters. So we have 0.05 millimeters, 0.1 millimeter, 0.15 millimeters, 0.2 millimeters, 0.25 millimeters, 0.3 millimeters, so on up to 0.9 millimeters, 0.95, and at the 10, that's a 1 whole millimeter. The vernier scale is attached to this jaw, and this whole piece slides back and forth along the main scale. So to measure the width or length of this object, we need to make sure that the external jaws are tightly holding it. If your vernier caliper has a bolt like this, you can tighten it to keep the jaws from opening. To read the vernier caliper, we look to see where the first 0 on the vernier scale points to on the main scale. In this case, the first 0 on the vernier scale points straight up to 10 millimeters. If the first 0 fell, say, between the 10 millimeter mark and the 11 millimeter mark, we would only record 10 millimeters. So here in this case, it's simple. The 0 points straight up to the 10, so we have right here, we have 10 millimeters. Next, we look along the vernier scale at the tick marks to see if any tick mark lines up nicely with a tick mark on the main scale. So I see maybe this 7 lines up nicely, or this 8.5, 9. I think the best one is the 0.95 millimeter mark right here. So I mark this. Now it's 0.95 millimeters. We keep note. And now all we do is add 10 millimeters, which came from the main scale. The first 0 on the vernier scale points to the 10 millimeters, plus 0.95 millimeters. So this is where the vernier scale tick mark lines up really nicely with the main scale tick mark, and I record the value from the vernier scale, gives me 10.95 millimeters. So 10 millimeters from the main scale, 0.95 meters from the vernier scale, add them up, I get 10.95 millimeters, or 1.095 centimeters. Again, to go from millimeters to centimeters, we just divide by 10. One more thing about the vernier scale measurement, the 0.95 millimeters. If you think another line lines up better than the 0.95 millimeters, like say the 0.85 millimeters, that's fine. You can use that instead. Use your own judgment in measuring with the vernier caliper. It's only a little more complicated than the ruler, and with practice, you get better at using it. The micrometer is even more precise than the vernier calipers. The smallest unit of measurement on the vernier calipers was 0.05 millimeters, whereas this micrometer can measure as small as 0.01 millimeter increments. This particular micrometer also only measures up to 25 millimeters or 2.5 centimeter lengths or widths. So we place the object right here in between the anvil face and the spindle face, and the spindle extends and retracts as we turn the ratchet clockwise and counterclockwise. As we turn the ratchet, the thimble also rotates. And so when the object is in position, simply twist the ratchet until the object is snugly fit in between the anvil face and the spindle. And to secure it, just twist the lock nut. Now the sleeve has this scale right here. Each marking on the top of the scale measures 1 millimeter increments. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 millimeters, 15 millimeters, okay? The bottom scale measures 0.5 millimeter increments, half a millimeter increment down here. The thimble markings, the thimble scale right here measures 0.01 millimeter increments. So this 45 represents 0.45 millimeters, and this 5 represents 0.05 millimeters. And the 0 is just 0 millimeters. So let's zoom in on these scales so we can determine the width of this object. So with the object securely in place, we can finally take the measurements. First, we look at the top scale on the sleeve right here, 0, 5, 10. And we find the furthest line to the right that has not been covered up by the thimble. So the furthest line on the top of the scale is right here, okay? 2 tick marks past the 10 millimeters. So that's 10 millimeters, 11, 12 millimeters. Okay, next we look at the bottom scale down here. and we see if there's an exposed tick mark down below just past the 12 millimeter. And when we look, yes, indeed, there is one. So we note 0.5 millimeters. This tick mark is exposed. Now we come to the thimble, and we look and we see where the scale on the sleeve lines up on the thimble. So making a line across the scale on the sleeve to the thimble, we see the line right here, just above the 0.35 millimeter line. So you can either say, you can round up to 0.36 millimeters, or you can estimate. Because it's not 0.36 millimeters, I'm going to estimate about 0.357 millimeters. Again, it's fine if you want to round up to 0.36 millimeters, but I'm going to use 0.357 millimeters, which is slightly less than 0.36 millimeters. If you look at this and you think it looks like 0.359 or 0.358, that's fine. We are just estimating this thousandth place right here. So now it's just like before. We add our 12 millimeters from the scale, the top scale on the sleeve, plus this exposed 0.5 millimeters. We wouldn't add anything if the thimble had covered this line up, plus the measurement on the thimble, which 0.357 in this case. So 12 millimeters plus 0.5 millimeters plus 0.357 millimeters gives me 12.857 millimeters, or 1.2857 centimeters. Again, to go from millimeters to centimeters, we just divide by 10. It's that easy. Finally, we have the triple beam balance.
Hi, this is Mr. Biter, and this is a quick tutorial on how to use a triple beam balance. The triple beam balance is one of the most common scientific instruments that we're going to use in science class. We use the triple beam balance to find the mass of an object in grams. Today we're going to find the mass of this iron cube. To begin with, let's go over some of the features of the triple beam balance. Here is the pan. We want to make sure the pan is clean and free of any debris or water that might be on it before we start. If we don't, that could affect our results. We would be taking the mass of the water or whatever's on there instead of the mass of just our cube. These are the arms. We want to make sure that when we start, the weight that's on these arms are all the way down here. It's what we call having it zeroed. And we also want to make sure that we have this lined up right here with each of these little lines on each side matching. They're lined up. Now, we also want to note that there are little grooves on these two arms where the weight fits into. We want to make sure when we move these weights back and forth, it falls into those little notches. Otherwise, we're not going to get the right results. So, let's take the mass of this iron cube. We'll put it on here. You know it's right away. This end goes whoop, right up to the top. We're going to start with the heaviest mass and move this over. Did it go down? No. So we have to go one more. That time it went down. Now we're going to move it back. We're going to go to the next heaviest. This one in the rear. Move it up. Move it up. Move it up. There we go. Now we're going to move that one back. Finally, we're going to go to the lightest one, the smallest little mass here, and we're going to move that across. Just tap it with your finger. Tap, tap, tappity tap, 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 tap. There we go. All right, that's lined up pretty good. All right, and we want to try to be as accurate as we can with the triple beam balance. It can be difficult, but get it onto one of these lines that you see on that front bar. Now, how do we know what the mass is? what do we do with these numbers that they're lying on? Well, let's go ahead and take a closer look to see what we really need to do in order to find out what the mass of this cube is. Let's look at the largest one first, 100. So that's 120. 120. And what's this one say? Well, it's right after the 5 before the 6. So that's going to be 125. How many lines over it is? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 125.9. 125.9. Now, what are the units for mass? Grams. So we'd want to report this as 125.9 grams. Now that's the basics on how to use a triple beam balance. Make sure you practice a lot so you know how to use this instrument.